Welcome to this video on FPOD data validation. This one is on weak unknown train sources, or WUTs. These are pretty rare at most sites, and you're kind of quite lucky if you spot one. But at some sites they're common and occasionally occur in very large numbers. Um, they can be very distinctive or not so easy to recognize. So we'll have a look at one of these. So this is from the Northeast Pacific, thanks to Christy McMillan and Barbara Merchant for this amazing data. So what you're looking at there, if you look at the middle panel, that's the FP1 file, and you see that wiggly line of click rate, which is kind of starting somewhere up near 3,000 clicks a second and coming down eventually in that very neat wiggly kind of profile. The Kerner F classifier doesn't track trains that are faster than 2,000 clicks a second, and it doesn't like very rapid changes in click rate. So the results it's giving up above are quite sort of fragmented. So there's a lot to be said for looking at the FP1 file, which in this case is the bottom three panels there. So I'll just show you the, will I? Yes, waveform and spectrum. Refresh. Okay, so here you can see the shape of the click kind of reconstructed by fitting sine waves to the peaks of these waves. So there's one click. There's the next, very similar. So only two were actually sampled like that, but that gave you an idea of what they're like. So we'll show the next screen. So this, I think, is also a WUTs, a weak unknown train source. What we saw with the last one, if I just go back, is that we're kind of looking at the whole train here, because it kind of starts there at a very high click rate. So it's not as though we've suddenly dipped into a train, which is what happens with a cetacean. It basically swings its beam of sound across the hydrophone, and you're not seeing the start or the end. But here, this train is clearly very different at the start, and then at the end it sort of peters out. The overall profile here of amplitude is fairly flat. I mean, there's structure within it, but it is overall fairly flat. The frequency content varies quite substantially through the train. So when we look at the next one, we can see some of the same features there. It looks as though this is the start. We're not just dipping into something that's going on, and it does kind of peter out there. And the click rate is quite high. This is sort of 1,700 clicks a second. The next one here is kind of got a structure which doesn't fit well with being a part of a cetacean click train. There's a lot of frequencies involved at the beginning, then it settles down there, and the click rate is showing variations that parallel those changes in frequency. Normally, in cetacean click trains, the click rate and the frequency content don't show strong correlations like this. Here's the next one. This one would do even better as a dolphin click train, but it's got this feeling that it's petering out at the end, and funnily enough, kind of at the beginning. It doesn't start very distinctly. If that occurred on its own, you really couldn't know what to say it was, and it's only 566 clicks a second. So this is why you can't take a single train, even if it's nice and neat like that, and say that's a cetacean. You have to have more than one. And if you've only got one, you have to be able to see in the FP1 file a sort of encounter structure where you're kind of seeing it weaker beforehand and then building up and falling off. Okay, here's the next one. Just refresh that. There's the click waveform. They're very different from the last one we saw. Very narrow band. They're at 82 kilohertz, and the FFT and the time domain estimates of frequency were exactly the same. Um, and the next click in that is the same and the same and the same. So these are very uh, they would be very unusual for a cetacean because they're so narrow band and long and uniform. And again, it kind of peters out. Let's see what the next one is giving us. Um, yeah, here you've got this kind of big mixture of frequencies. You've got this very smooth sweep in click rate. I'm looking mostly at the FP1 file here because it's actually easier to see the details there. The kernel F classifier doesn't always handle these well. They weren't its sort of target. Um, yeah, another one with a strange jump in frequencies. And then we get to one here that is rather like the one we saw originally. You know, we've got a very clear kind of start with a louder peak and then it peters out. The frequency changes a lot through there. A thing to notice is we have got multipath here. You know, we've got two clicks together and you can see them there. There may be three there. It's quite unusual to see more than two, and actually it's quite unusual even to see two. So this looks like two different Watts train sequences. So I'll just go forwards and see if we get some more. Yeah, so here's a rather different style. So we're getting a lot of different sort of structures to this. Let's see what the kernel F classifier did on in clicks. So it did manage to follow that from 2000 clicks per second down, but the raw data said it actually started at 4000 clicks a second. Um, okay, so here they are, just amazing things. Oh, here's another one where we've got a waveform. So that would kind of do for a dolphin click. It's different from the ones we saw before. Um, yeah, so okay. Um, so that's what's alike. I have got some data here we should have a look at. This is kindly provided by Jitao Wang. It's from the Yangtze River in China, and it's got a lot of these quite extraordinary trains of unknown source. So it's got a lot of the characteristics that I just talked about. You know, it appears to have a very distinct start. Um, we It's got a lot of frequency variation in it. You can see it in the colors here. It's got these very, well, not so very high, that's 500 clicks a second. This very smooth sweep here. And it goes on for ages. You know, it's still going, and other watts are occurring, sort of superimposed on top of it. Um, and the longest of these that we've seen in this data is actually covering something like 12 minutes. Um, and if I kind of move forwards through the data, you see these sorry, gone the wrong way. These very high click rates. Um, and most of these have got this very smooth down sweep, sometimes with a step in it. Um, these hardly look biological, but there are a lot of them. You can see it here, and they're louder than this kind of quiet, low frequency background noise. This pod was actually fixed to a floating restaurant or something like that. So whether that's in some way connected, but they're very clean signals at high frequencies and very high click rates. So they haven't propagated far, or uh, they would get muddled up. Um, okay, so I hope that hasn't frightened you too much, because actually it does rather frighten me, I have to say. And I've just sort of summarized here the features of what. So you're often getting a complete train. There may be a few local repeats of the train, or somewhat different versions, but there's no kind of encounter structure. The amplitude profile is often rather flat through. It may have small bumps, but there isn't the sort of nice humps you get generally with cetacean click trains. And the initial clicks are often louder. There are often marked frequency changes. Multipath clusters are unusual. Get a lot of modulation of click rates. Um, and they may be broken into multiple regular chunks, and they can be several seconds long. So, currently we're thinking that most of these are biological and they come from more than one species. Um, the frequency of species in the Kerner F classifier is often unclassed. So if you see a big patch of data with a lot of unclassed clicks in it, um, that's a kind of warning that you should look into that. It may be one of these Watts storms, um, and this does basically make the case that you do need to validate every file. You need to look at it starting with a kind of low resolution display, looking at all the species um, classes and all the quality classes together, and seeing kind of if there are odd features there. Okay, I hope that hasn't frightened you too much. I'll just leave this running for a little bit longer.